presented at the last meeting, the March 15th, around the life cycle costing, the maintenance cost elements. And also, after the session, Mert distributed this survey link to the group, so we can take a quick look of how the results pan out. So I don't know, Cello, if the results are ready from the survey.
Yeah, I'll go check right now.
Okay. And then yeah, we have Eric from the Team Energy to present us on some of the discussion that they're having in their group with respect to asset lifecycle costing. Obviously, energy is one of the key elements in the operating cost of an asset. So we want to see if there's any sort of alignment and synergy there. And then next, Mert can share a draft template for asset lifecycle costing model. We discussed a couple times about how we're gonna assign variables for different utilities in different circumstances and how it will calculate the overall lifecycle cost of an asset. And then I can briefly discuss about the lifecycle costing business processes. And this is to allow other participants in the call to sort of share their experience and their progress around some of the processes that are related to asset lifecycle costing. So I'll share some sort of a skeleton later today, and then next steps and closing. That's sort of the agenda for the next hour. Any questions?
I can bring this up again when I talk about it, Chris. But as we present the skeleton life cycle costing model, I would allow everyone to sort of critically think about sort of potential edits to it, and we can discuss it as part of like either next steps or during the presentation of it. But just think about like how it may be applicable to you and what would make it better. From your perspective.
Good point. Okay.
Yeah, that sounds good. And I don't know why we can't have a cool name like Team Energy, like what, like that risk team doesn't sound as good. All right. So Chris, did you want me to at least, start, or do you want to start with presenting what your data work from last time?
No, I can start what I presented, and maybe Mart, you can just do a quick recap. So basically, I presented the those pumps in our asset naming. So I basically search all the pumps and then see if over like the 5-year period when we actively collect the maintenance data and how sort of the corrective versus proactive and preventive, those different maintenance work order types are rolled up to at the aggregate level. And one of the findings was the corrective work order has the highest portion of the overall, and it was around like 7-8% of the replacement cost that's being recorded in our CMMS is used for the annual maintenance, whether that's corrective or preventive or planned maintenance. And then I also presented the individual pumps level, and the observation that I made was if the pump is very expensive, it's a very big pump, then the maintenance cost, the percent wise is a fairly low. I think it was below 1%. Whereas if the cost of the pump is cheap, then the percentage of the work order against the pump relative to the replacement cost is fairly high. It was over 10%, which makes sense because it's the basically same staffing who's looking after these pumps, and maybe the material costs will be different, but the sort of the foundational the work elements is similar whereas the replacement cost has a huge gap between the large pump, which was over 800,000, versus the small pump that I looked at was $5,000. So that was my sort of observations and materials that I presented.
Thank you, Chris. And in our case, we had data from starting from like 2010, 2011 timeframe on labor cost and equipment and material cost on a per asset basis. So we extracted those. Interesting things, of course, is that once you actually dig into like a detailed data extract, obviously just in every extract you start noticing sort of data gaps or data quality issues or certain practices that sort of potentially sway the results. For example, like an asset is retired and then it's marked as retired in the asset name, but it has accumulated data up to a certain point. And then if you still blend it into the average as if it's an active asset, if you're looking at like a gross aggregate data, you're really diluting your data because that asset is actually not incurring any costs, even though its replacement value is still part of the total replacement value of the assets you're looking at. So there may be some, we're noticing those issues. Like I remember, like we started when I got the original extract from the system with the help of our business analysts. We had over like 8,000 records, basically about 200 or so pumps, 8,000 records, basically like 40 work order per pump on average since 2010. This could be really, some of them obviously more, some of them less, right? Over so many years. Anyway, the point being, once I was done with all the cleaning, I applied to that data set. It was basically gone. It from 8,033, it went the data set that I ended up with was down to 4,315. So almost like a 45% attrition rate. Some of those are, legitimate removals, such as, a sump pump or some sort of like a, peristaltic pump is not really the same as, like a, water pump at a pump station that's hundreds of horsepower as pumping things. So it's not really apples to apples. The reason why all that stuff comes across when we do the extract is that they are all marked as pump. And our system currently, it's a gap, doesn't really separate it around like kind of pump or size of pump. So you have to like do that after the fact. So this also basically is a lessons learned in that, which that particular lesson we knew, and we are working on getting that addressed. However, lessons learned in the exercise that, you can't always get what you want when you're getting data extracted. But we did look at, with the information we were able to clean up, we did look at things, and Chris had even better numbers than I did in terms of like better charts than I did. But I'll just quickly show that, this was what you see on the screen is an aggregate data, all the pumps and the pump motors combined, and change in, proactive and reactive maintenance dollars over time as a percentage of estimated replacement value for these assets combined. So obviously this is aggregate number. You can imagine that you should be able to filter for like one asset, and then it would tell you the distribution for that one asset. Looking at numbers aggregate helps a little bit just because, we don't really have exact, install dates sometimes. And, different assets at different points in their life cycle incur different costs. So this kind of just tries that good old like big data trick in that, the knowledge of the masses is better than the knowledge of individuals combined, sort of thing. Anyway, so that was the finding there. Some guidance in terms of like, percent, like, replacement value, or, assigning a certain number of as a percent of replacement value for activities or maintenance activities. Not exact, but it got us in the ballpark a little bit. Okay, I think I can stop there. Thank you. What was the next agenda item? I forgot already, Chris. Short-term memory issues.
Sorry, I was muted. So the next item in the agenda is the summary of the survey that was distributed.
Yeah.
in mid-March. So Cello, could you share the results?
Sorry, I was on mute, so you could you can hear me. Just a second.
Yeah, it's good.
Is this okay now?
Yeah, we see it.
Okay, so these are the answers. We had 7 responses. So the first one was about the organization's asset inventory / register. And they were really patterned or practically the same as those AWWA surveys, the questions, so we can compare ourselves with general in the industry. So this was in terms of assets are organized as part of a well-defined asset hierarchy. This is yes is I'm not sure, what do we call it, this color? Orange? Red?
Yeah, orange, copper, I don't know, maybe.
Okay, let's call it red. So and then the basic attribute data is largely populated, most cases, and inventory contains more than 75% of assets. These are the specific results.
Oh, okay, 86% almost.
Yeah, and this is, and here is, these are the. So the second question was, does the organization have a process in place to assess the condition of vertical assets and store in a spreadsheet or database? So this one was yes, is 28%. Sorry. So is it big enough so that you can see the yes and the no?
Yeah, I can.
Okay, so this is the second one. Assessment results are stored in a database for future analysis and reporting. It's about half and half. Condition assessment conducted on some non-critical assets. In addition to critical assets, it's about 57%. Condition assessment is conducted on vertical assets to identify defects and trigger immediate intervention problems. It was 71%. I will post this to the OneDrive, these results after this call. So this is the second question. The third question is, does the organization have a process in place to assess the condition of linear assets? The other one was vertical, and it seems like good response on that some advanced condition assessment technology is used to inspect critical pipes for more detailed condition data. 71% pipe condition information is in a database is linked to asset registry inventory. And condition of pipes is assessed using a break database that is 20+ years old and comprehensive. That's, it's basically 1 out of 7. So the next question was, does the organization have a process in place to assess the probability or likelihood of failure of assets? The first question was, probability of failure is established for more than 90% of assets using asset age and expected life only, and using failure data, asset condition or other advanced method. So yes is 1 out of 7. Anyway, so the first one was expected life only, whatever. Sorry about that. And the probability of failure is established for more than 50% of assets. 4 said yes, 3 said no. probability of failure is established for less than 50%. Again, it's different, 42, 3 versus 4. And a process is developed but has not yet been significantly implemented. So that is, yes is 71%. This is the last question. Does the organization have a process in place to assess the consequences of failure? This is for more than 50% of the asset using a simple relative system. That is 1 yes and 7 no. This is including triple bottom line. Yes is 2 and 5 is no. It's difficult for me to simple relative rating system, and this is for less than 50%. This was more than 50%, and this is less than 50%. And process is developed, but has not yet been significantly. It's 4 and 3. So these are the results. I'll put the PDF into our space. So back to you, Chris.
Thanks, Cello. That's very interesting results. I want to see in more details and see if there's any conclusion that we should draw and improvement that we can implement. So
okay.
So thank you.
Okay.
So the next. So yeah, if you can unshare your screen, Cello. Thank you. So the next agenda item is the Eric to speak about the team energy initiative related to asset lifecycle costing for our topic. Eric.
All right. Good afternoon, guys. I don't know how much I'll have as far as the with respect to the life cycle costing. I'm just going to kind of update you on the activities of the team energy. Along with the awesome name, GLWA recently rolled out some awesome PowerPoint templates. So you get the courtesy of getting some of the best work at GLWA with these new templates. But I did want to give you an overview of our system. We're in Detroit. We are on the water and the wastewater side. So on our water system, we have 5 water treatment plants, 19 booster stations serving 3.8 million people. And an idea of energy usage, if this is just kilowatt hours for our water side. Here's our 5 water treatment plants. You sum those up, you have 220 million kilowatt hours on the water treatment, 100 million on the booster stations, and then we have various remote sites that are used to control the system. So on the water side, we have over 323 million kilowatt hours for our water facilities. And then on the our wastewater system, we have one of the largest treatment facilities in the nation, our water resources recycling facility. We have 8 CSO facilities, 9 pump stations, a treatment capacity of 1,700 million gallons per day, primary treatment, serving 2.8 million people. So Detroit and suburban areas on both the water and wastewater, they don't serve the exact same areas. So on that side, with just wastewater treatment, we're at 152 million kilowatt hours, 25 million kilowatt hours on the pumping, 7 on the CSOs for a total of 180. So over 500 million kilowatt hours go into our utility. And I'm the one who manages all that energy. So now I do have another person on my team to help with the power quality work. But I guess I'd just say that I'm not that much different than most of our utilities, is that we're using a lot of energy and we don't have a lot of personnel focused on this information. So the WEF-WISE project was really interesting to bring utilities together and discuss energy management. So you guys should be familiar with the project, looking at where we are now. We're doing the maturity assessment and ultimately developing business processes, really turning the data collection, making it accessible, turning it into decision support. But you know, a lot of in the energy management side of things, we're doing a lot of these things, but the business process element isn't necessarily in place. So here's our different teams. Team Energy is right there next to asset management, and up in these more technical teams of the CIP planning and delivery, the asset management really relies on metrics. I mean, I listened to Mert and Chris talk about the data you guys are looking at. The energy is the same way. It's a data-driven activity. So I have gotten some involvement in the team data analytics to try to understand what different utilities out in the country are doing, because there's a lot to learn from each other in this process. So we kicked off the whole thing. The team kicked off in September, so we were one of the newer teams for the project. And we start off with what does energy management look like at your utility, the challenges and pain points, and what are the goals. And through those conversations, you really saw that the different utilities approached it different ways. I have a career of data management and data analytics. So I've been in this role for about 2.5 years, and I jumped in with just like give me all the data you can, dove right into the weeds and see what can I see about how pumps are performing, how much energy is our different facilities using. But we have other energy managers that are really focused at more of the executive level and more about policy and more about you know, green initiatives, which is a big driver everywhere, but can be in our industry, and things like that. So we kind of had this group, and we all took turns discussing what we were doing at our own utilities. And I kind of had come up with this about a year or two into my position. Is at GLWA, it's an energy program, and I'm like, what is my program? And these are kind of all the things I put together of things I'm working on a daily or weekly or monthly basis. And I kind of brought this to Cello and Mike and said, yeah, here's my energy program. And they said, oh, wow, you're doing a lot of stuff, and that's great, but there's some flaws in this. And this is really just a summary. This is just like, here are initiatives and activities, and they are task-based, and they're not really related to any sort of goals that, you know, I'm trying to achieve as the energy manager or GLWA is trying to achieve as an authority. So kind of encouraged me to look at this a little differently and develop a goal tree, which is something I wasn't that familiar with, but I took a stab at it. And it's like, what are my goals? What are the organizational goals? That would be your top one. So organizationally, reliable water and wastewater service to our customers where we use energy reliably. That's like a fiscal side of our commitment to our customers. And I kind of split that up into more what can enable those goals, and energy usage and costs targeting, reliable service, which is not as much on the traditional energy management, but to us that's also of critical importance, and it kind of falls into my purview is making sure we're not having pump trips that are losing service to our customers, and then improve energy efficiency. And then we just, from there, the goal tree is about like, here's a goal, what enables that goal? What are the goals that enable that goal? So so for the reliable service, mitigate interruptions, make sure that the facilities are power metered where we have power quality data that'll support our ability to serve our customers. On the energy costs and targeting side, we kind of have a lot of different things. There's a rebate program. We're utilizing that. We're auditing our accounts, reviewing our bills. Things fall in that category. And energy efficiency is to look at our process energy efficiency, building energy efficiency, our process data, and utilize DTE, who is our provider here. We have a agreement with them where they provide an energy manager, and he comes with a set of tools. So utilize that so that we can improve our overall energy. So this was my first iteration at Goldtree. Everybody really thought that was great, and I was getting somewhere. But we kind of said, okay, from there, how do we do those things? So then we kind of on these started to look at KPIs. What things are we doing for those individual goals that we're tracking, that we're making progress towards them, or activities around that. So this was all an initiative that was really supported greatly by Mike and Cello. And one of the things with the Goldtree is it helps you develop into your business process models from the Goldtree, because you're trying to you have your goals that you're trying to achieve, and how do you what's the actual activity, the process that you do to achieve those goals. So we said, let's take some of these activities and turn them into a business process model. Ultimately, that is one of the core things that we're looking for on the WISE project. So the ones highlighted, I kind of said all these kind of fit together. They all involve sort of the same process. So this was my first stab at a business process model. And it kind of worked with Mike. I hadn't had any experience with this, and I said, well, this is what happens. It all starts, we get monthly billing, and we get this bill, and from there, we're doing these activities to support managing our efficiency and managing our efficiency projects and managing our costs, tracking. So we take our bill. We parse out some data out of that bill, and we do have a system that helps us with that we use a service called Capturus, that they actually receive the bill and parse the bill and provide data, web-based interface to that billing data. So we get this, and there's more to our bill, and this is probably the case for you guys as well, is than just cost per kilowatt hour. We have like a demand charge, and we have a 65% of a demand charge, and all these things that there's more to managing our usage and lowering kilowatt hours. So that's part of why we do that step. And process data is basically like our production data. So our energy usage is going to track with that. So we normalize it to not just we're going to lower our energy usage, because if we have twice as much rain this month as last month, we're going to need more pumps running to move that wastewater. And on the water side, when we're in more of a drought condition, we're pumping more water to meet our customers' demand. So we use that process data. We also use heating degree days, which is used and more on the natural gas side to normalize the data. And all these things are inputs to normalizing the data. And then this is my first iteration, so this has changed, but we have a signal to start looking at our energy efficiency project portfolio. Then this piece, when this is a very small thing that I threw into here, it's part of the DTE energy toolbox, but they want us to identify energy savings projects, and they expect us to work on those, to have action on those. So we have to evaluate those projects to see how much fiscal sense they make, how much resources it'll take, all the things that go into. So where Mike's note here, this is kind of like the CIP business case evaluation. There's a step in here that we have identified these things that can be done. How do we deal with those? And that is in that energy manager toolbox. From there, just for this step, we have a process that placeholder for implementing those projects. And then we have a bunch of KPI reporting and dashboards based on all these things that we looked at so far, the process data and the energy data, the billing data, where we have a series of KPI reports and dashboards that I've built over the past couple years to track our performance. So that was our first iteration. We brought it to the team. We had a lot of great discussion about it, and one of the flaws I saw, pretty clearly in here is it was a small. It didn't really encompass all the other pieces of the organization that it should. So our next iteration, we put in the swim lanes, where when we talked about process data, we have a piece down here for operations where not only do we kind of look at the process data, but there may be instances where the process or the billing is kind of telling us there's something going on that we may need operations to tell us there's something that's changed out there. We may have a pump station that's bypassed, so we're pumping from a different one for maintenance reasons. And so we do have a confirm operational deviation or investigate usage part in here now. Still in the core of it is all up under the energy team. We did flesh out some of the reporting with our energy database is a key piece here. Power BI is where we're doing some reporting. And then finance has a piece of this puzzle. Those financial operations of actually just paying the bill, watching the budget. They're in charge of the system that actually is parsing the electrical bill, that capture system. So we've identified different roles here in this particular. This is still kind of that same scope of being a smaller process of billing and usage and production is kind of the scope. So that's still a smaller piece of an energy program or energy management. So then Mike kind of brought forward this one, and I apologize that you can, if you hit control or whatever in the mouse wheel, you can zoom in. But Mike found this as in a paper of the industry energy management program, where it goes a lot broader range, and that's what we were looking to do a little bit, where we have some a planning step where we're doing the bigger energy projects to identify, some real energy saving targets. This piece right now is, is a piece of a piece. We don't have many energy focused projects. We have a lot of projects, and we're putting the energy focus into that project. We're replacing a pump station. I'm involved with that, with looking at pump efficiencies and stuff like that. But this template to me was a little bit more of if you were doing a project solely for the energy savings. But still, it has a lot of that higher level view that we're looking for, and also some of the pieces of interfacing with the top management to initiate some of these programs. So with that, our next step right now is really seeing what other team members can take pieces of processes and implement their, and develop their own business process model. So that's what we're doing right now. For David Ponder will be presenting tomorrow on on his energy policy for his organization up in Minneapolis. So that's where the team is now. Is we're trying to expand our library of business process models related to energy management. And that's pretty much what I had for the team today. Like I said, it was more of a status update of where we are as the energy team. I don't know how much that fits in with what you were looking for, Cello, but you know, that's you don't give me much direction, and I freeform it.
Yes. What the reason that I thought this would be very useful and appreciate you doing this is because we'd like to look at specific sub-processes within the asset management and risk and see if there are elements in that model that we can go kind of considerably deeper and do an equivalent to what Eric has done. And I see Mert has his hand up.
Yes. So thank you so much, Eric, by the way, first of all. And second, you know, perhaps a little selfishly from the asset management / risk team's perspective, you know, one of our challenges when it comes to so we selected life cycle costing to develop a little of a tool as a process in the development of an asset management plan to dig in a little deeper in this phase, in case you didn't know that. So. And of course, when it comes to life cycle costs, you know, power and energy, you know, could be significant depending on what kind of asset you're dealing with, you know, really significant, right? So, but of course, the challenge is if you're going to do things at like a per asset level, like it's rare that we actually do like sub-metering on individual assets, but generally we do have obviously the power, you know, the energy meter for a facility, one or two. So I really like the whole like the normalization exercise you talked about, you know, I'm guessing like seasonal normal temperature, process usage rates, whatever, all that good stuff. Now I was wondering for what we need to do, if it's possible to take that, you know, one step further, obviously without sub-metering, you know, I was thinking about how to do it. I guess so my question is, has internally as an organization you or as the energy team sort of entertained some ideas on that one? Like one suggestion that comes to my mind is that if we have sort of like seasonal average normalized energy usage data for a given facility with like obviously, you know, lots of energy using equipment in it, I was wondering if there was a way to look at like run hours and the you know, VFD settings and the energy efficiency estimates and, you know, like, you know, horsepowers, and basically come up with some sort of like, okay, if we spent, you know, 100,000 kW here, how are we going to do like a weighted distribution of this to all the assets that actually contribute to that? Is that like, does that, you know, I mean, is this even meaningful? Does that ring any bells? You know, is there like other ways to do it? Anything to that effect?
Yeah, I wouldn't necessarily discount sub-metering, especially if you are putting in assets. So I would be, maybe I'm biased because I'm in energy manager, but if you're putting in new equipment, I don't think it's that hard to put in sub-metering, and I think it can provide some good value. But I think the hidden thing maybe that you may not realize is if you have a VFD and things like that, you may have energy data that you don't know about. And you probably do actually. So a lot of motor protection equipment has energy usage in it. VFDs can have very sophisticated energy usage information in them. In our case, it's a real challenge that this is older stuff that's not networked, let's say, you know, and everything's on our secure network. So getting the information off of him is challenging. I look at equipment all day long that has energy data, but I can't get it into my hands very easily.
Oh, that sounds frustrating.
Yeah, but I mean, but I don't want to make that assumption that every place is like that. But I mean, we have the multi-lins, our old, you see old serial RS485 wired into it, but it's like kind of wired to nowhere. So so look at that equipment that, especially on, this is, you know, really for the big pumping units, right? Mm-hmm. And that's going to be a big chunk of your energy usage. The other thing, so we recently did a metering program that has did 3 of our water treatment plants. So now we have the metering on the mains and the metering on all the major pumping units, which is high lift, low lift, and wash water. And so I'm gathering data right now to kind of, first this is something I'd love to share someday, you know, as like a real world, here's some things maybe to build estimates off of or something like that, is look at what our real life energy usage versus horsepower. I mean, if you convert it to kW, it'll give you a number, but what's our range that we operate in? And then we're looking at like, what's our total high lift, total low lift, as kind of a percentage of operation, and then what's our leftover, as you know, maybe you can make some estimates of your what your building envelope, your actual auxiliary power is, if you take that off. And the other thing that where I started before I had a lot of metering is our utility does have half-hour data, which is decent resolution. You can go to the DTE website and download half-hour data. So for a lot of facilities, I rely on that too. And half-hour, when you combine that, like you said, with a runtime, now you're kind of getting somewhere. You can almost, you know, in the power data, you're going to see that pump turn on, and then you have that runtime of what you can start looking at deltas and things like that. It's some legwork, but I think there's some opportunities there.
Mm-hmm. No, thank you for that. Thank you for that answer. We do that too. We shut off the pumps to get the baseline expense, and then we can add them one at a time. Because when we don't have the sub-metering on existing stuff, that's one way to deal with it. But yeah, thank you for your answer and thoughts.
Deborah?
Thank you. To take that, I'm not sure what David Ponder, who's in MCES, has to say. I'm interested and asked Cello to invite me so I can listen to David, because David's done a lot of work. But I think my one thought without asking David is maybe the people who, like for instance, he works very closely with our big energy organization, which is Excel, or I think it's Excel. Yeah, it's Excel. And maybe even through the grant process, you could get some of that picked up, because they have, you have to prove an energy savings, and you can't prove an energy savings unless you can baseline it. So maybe anytime you're hooked up to do grant work, that they might be able to help you with that. So you might be able to go back either from previous reports or going forward with those energy companies that work with on grants. They should be able to help with some of that too.
Yeah, temporary metering is basically an option, and DTE, the energy manager who we have as a resource, can help us with that if there's areas we want a temporary meter. But with some of this equipment too, that's not easier said than done. When you're at 4,800 volts and things like that, it's not always easy to temporary meter.
And I didn't realize that treatment plant was so big, Eric, actually. I wonder, like, if you could market it as the treatment plant you can see from space, or something.
Yeah, it's pretty large. Yeah, we use about 20 megawatts on an average demand.
Mm-hmm. Okay.
Yeah. Before we go next, I just want to share one thing. I don't see any hands. I want to share my screen. This is what I will post to actually I posted this already. This is the result of the survey that we have, the 7, and then this is the result from AWWA report for the same question. So this is the question that we asked in our survey, and then this is the same question. This is from the AWWA report, just as a reference. So I will, this is already posted, but I'll make it just a little bit cleaner and add some notes. Just wanted to let you know because somebody asked if this is going to be shared.
Thank you, Cello.
Yeah. So yeah, so the idea, one of the things that we've been doing recently is a little bit of sharing between different teams. because we thought, okay, some exciting things are happening with asset management, and maybe the technology, and on the technology track, for example, the digital asset management plans is really tightly connects the asset management folks with the technology and data analytics. So we're going to try to kind of cross-pollinate, and we thought that what Eric did with his business process, that he went, we really get the value out of these business process models if we go down into the weeds a little bit and really identify the metrics and the measurements. So that would be nice if we could find, if people could identify a specific sub-process within asset management and then try to do something similar to what Eric's done. Any thoughts on that?
Yeah, I just have one question, Eric. There was a really great materials to understand. Just curious, out of those metrics that you define in that sort of a tree format, is one of the next step to ask the participating utilities to sort of provide some baseline, the scoring base, like for each of those metrics? Just want to see how the metric will pan out depending on which utilities you're coming from and how much data you're collecting on energy and stuff.
I don't know if right now I had that as a goal. I hadn't really thought too much about collecting the data that the other utilities have. I mean, I've thought about that a lot in other aspects, but not on this project, because we don't have readily baseline data out there as far as what's typical kilowatt hour per MGD in this type of process. So I think at this point, the developing the business process models has been valuable to me, and I'm working towards that for here. But I think once we make a lot of progress there, that would be a really interesting, direction to go in. But I'm also have a lot of data, a lot more data than like some of the other utilities, where they're kind of trying to get this information, where I'm a little further down the road on having a lot of sub-metering, a lot of process data.
Mm-hmm. Okay.
Everyone's at a different state,
That's a great question, Chris. And I see Deb has her hand up.
Well, you're right. It is a great question. And I know that David Ponder has been working really hard in ES to, try to further doing the connections between what we do with our assets and getting the energy costs. And he's really doing a great job for one person. But the tree that Eric showed for me was, wow, I think that I can take that and I can have, it can help me to drill down and to make more connections. And then with the crossovers and, with the different assets, we're just starting to have conversations on what do you have and how, how do you maintain it, and then when do you replace it? We're just starting to have those kinds of conversations where they can actually apply dollars to what they actually do. So I can see a connection, and I just need to play with it a little bit more to be able to see how I can cross-pollinate.
Yeah, that sounds really good, and I think that what would be great is the more communication, peer-to-peer communication, the more value it can bring to different utilities, and the foundation really is always to start with defining the business process and the business process model, because there's so much knowledge that we can gain from that, who's involved with decisions that are made and stuff like that. So we thought that the stuff that Eric has done.
Well,
on
you
the
have to
energy.
give me a quick debrief because I have a 2 o'clock and then I can call you after that.
Okay, so that that we can apply similar principles to the stuff that we're doing in other initiatives. So that was really, you know, why we thought that it would be useful for Eric to show what he's doing on that end. Like this goal tree is something that may not be a bad thing for us to do on this asset management side as well. Any other thoughts or comments? We were gonna, I don't have the agenda. Do you have the agenda, Chris, that you could share again just to see what?
Yep. So I think yeah, we are at discuss the draft template for SLF cycle costing model. And then we can also discuss the business process for life cycle costing at a high level to invite some future presentation from the group.
Okay.
We have about 5 minutes, Chris.
Yes.
I'll try to just squeeze it into 2 minutes then.
Sure. Yeah, I was
okay.
thinking the same.
Okay.
If you think that this would not do it justice, we can maybe postpone it. It's up to people. If you'd like to, because I don't want you to rush through it, is my point, because it's only 4 minutes left. So maybe it's better to leave it for next time. But what would be great is if there's somebody in the group who can see a possibility for maybe developing similar goal tree on the asset management side, maybe not for the entire, but just for, you know, a sub process. Are there any takers on that? Okay, if you do, give it some thought and decide you'd like to do something like this, just let me know and we'll make the connections and you know, enable that conversation. And what do you think, Mert?
I'll just add one thing. I mean, we are out of time, so let's not push it that hard. But I just want to note one thing here real quick for people to think about, and I'll describe it in more detail later. But if you'll remember, we talked about developing basically some standard decay curves and maintenance cost curves and using those as basis for life cycle cost changes over time to an asset. So I just want to show you that, you know, this was relatively straightforward to create, like condition change over time, as percent life cost consumed versus condition change. This one is, I'm not too worried about it, but on the maintenance curves, like I couldn't readily, you know, when I did this, I couldn't readily come up with like a bathtub curve equation that represents things nicely. Where, you know, you start with like a higher maintenance cost in the first few years, perhaps, and then things settle down to a steady state and then increase. So I'll describe all these in more detail, I guess, down the line. But if you're aware of any equations that you use internally to represent bathtub costing change over time for maintenance, especially for an asset, just reach out, please, and then maybe we can revise some of the equations shown here. And I'll go over it in more detail, I guess, at the next opportunity.
Yeah, I just want to make sure that Chris has enough time to do his stuff and not try to shove things into too short of a time frame. Any thoughts from you, Chris?
No, I agree. So let's not push the 2 items and just address them at the next meeting. It'll be nice to know if there's any sort of potential presentation from other other participants as well. And like, I don't know, like you know, Deborah, we're talking about some of the MCS work that can be presented. I mean, Scott's not here, but he mentioned a couple initiatives that are related to the SLF cycle costing that can be presented and shared, right? So
yeah. So Casey and Noemi, if you have some thoughts, I'm not going to call on you. at the last minute, but if you have some thoughts and stuff that you could maybe engage on, just please send me an email. Same for Bill Fritz as well, if you would like to take some of these things on. And again, it's a peer-to-peer collaborative thing, so everything will, be shared.
I don't have anything off the top of my head, but I will look and see what we have.
Okay, sounds good.
Yeah,
So
me too.
okay, thank you. So Mert and Chris, we're at the top of the hour. Anything else you wanted to bring up before we go?
I'm good.
Just say thank you again, Eric, for taking the time. I put it in the chat too, but thanks for taking the time to present. Thank you.
Okay, well, thank you, everybody. And I will stop the recording, and I'll post the recording and Eric's